Hey, this is Joe at graybenchelec. Welcome back to the pedal teardown series where I take apart new and interesting pedals and show you what's going on inside. Today we have the JHS Pedals Bender. All right, so we got the JHS Pedals Bender. This is a new series they came out with several, or I think it's 4 different fuzz pedals. This one, of course, is based on a tone bender. Specifically, I believe it's a Mark III tone bender. The original Mark III tone bender from Solo Sound was a germanium pedal. This has silicon transistors. We'll see that in a second. As for the externals, we have 3 controls on top: volume, tone, and attack. We also have input and output jacks, 1/4-inch jacks. They are in the standard configuration with input on the left and output on the right. 9-volt DC jack. No polarity marked, so it's probably fair to assume it's going to be center negative. At least you would hope so if they didn't mark it. On the side, we have a switch called mode. This would be a JHS edition. The original tone benders didn't have any mode switch. Foot switch feels like a standard latching foot switch, triple pull, double throw probably. Little red LED for indication telling you if the pedal's on and off. The placard here appears to be metal with the silkscreen or UV printed text. We have Bender, 1973 London, JHS pedals. The controls also have their own metal placard. The mode switch has its own placard. The enclosure, as you can see, it's a folded enclosure. Looks to be probably 18 gauge or so, held together by a couple of screws. The enclosure does have a notched screw hole here, so you can actually just undo these 2 top screws and then it'll just hinge open. On the back there is a sticker with some information. Oh, actually here's the polarity marking. So the polarity is marked here, and yes, it is center negative. That is about it for the externals. Let's go ahead and crack it open. I'm just going to pause the disassembly here for a second. I've discussed this problem on other pedals, which is that when you have an enclosure with fixed sides, right, we can't disassemble the enclosure. It's a solid shape. We could bend it, but we wouldn't be able to get it back. And you have components sticking through the enclosure soldered onto the same PCB. So this, we can see there's 2 PCBs here. There's a main board here and a little daughter board connected with this ribbon cable. But when you have components connected to the same PCB soldered in that stick out of the enclosure at right angles, so we have the pots sticking out top side like that way, we have this mode switch sticking out this way. In order to be able to easily remove this from the enclosure, you need to do something to figure that out. Because if we wanted to pull the PCB down to clear the pots, then the mode switch interferes. If we wanted to be able to pull the mode switch this way, the pots interfere. In this case, we're also complicated with a third dimension, which is the foot switch here is coming out the back of the PCB. So we have our X, our Y, and our Z conflicting with each other. We've seen this problem duplicated on pedals like the Klon KTR, but you saw there that Bill Finnegan actually made wider, rectangularized the hole for the pots so that it could slide in the enclosure just enough to clear the buffer switch on the KTR. In this case, there isn't really any consideration, and so you're going to have to kind of bend something in a not pleasant way to get it out. In this case, there's not a ton of movement available on the pots. The clearance is pretty low there. The mode switch, there is a little bit of clearance. You can also push the mode switch in to hopefully clear the enclosure. The foot switch is really where it's going to be tough because it's a pretty tight fitting hole as well and large. And so I'm going to try and just hopefully work it up and out. But you can see here the pots are twisting in the enclosure. They're kind of hitting. It's one of those things where it's like, ultimately, if you're not taking apart the pedal, does it really matter? And I guess that's true. But sometimes things need to be repaired. All right, so now the foot switch is clear of the enclosure. It's kind of putting the pots at a weird angle, and you can see it's also kind of pushing the mode switch. We try and push the mode switch in to hopefully get out. Just trying to do it carefully to not stress it too much. So, not ideal. It's putting stress on the components, especially the mode switch here when you're pulling that out. A little bit of damage to the sides of the mode switch. Nothing that's going to affect the actual operation of the pedal. It's just, it would have been nice maybe if the pots were on their own little board like the 1/4-inch jacks are here in the DC jack, or if the mode switch, maybe this cap could pull off and then it would clear, something like that, or the foot switch was on its own daughter board, would at least be a little bit better maybe. All right, so in the enclosure, there's a little piece of foam here. There's also a lock washer, star washer for the foot switch, which probably isn't terribly necessary unless they're grounding there, which doesn't seem likely. Actually, there's actually a question of where we're getting ground at all. I'm not sure where enclosure ground is being connected to. Maybe it is the foot switch, which would include the star washer, but usually you'd expect to see somewhere where paint or powder coat would be removed or prevented from adhering to the enclosure to get a good ground connection. I'm not seeing that anywhere here. So they might just be depending on the sleeve here of the 1/4" jacks touching the inside of the holes to make a good connection. I'm gonna guess that's probably where they're getting it, or perhaps it's could also be the potentiometers as well. Those will probably be grounded the enclosure of the potentiometer to the enclosure, perhaps. So there's our enclosure, folded steel enclosure. At least it feels like steel. It's heavy enough to be steel. So here's the PCB assembly. Like we saw before, we've got 2 boards. This smaller board here is just gonna be for the 1/4" jacks and the DC jack. You can see there's 3 traces coming out from the input jack here. That's going to be to turn the battery snap on and off. The output jack just has 2 traces because we're not doing any switching with that jack. DC jack, 2 traces as well, of course, positive, negative. Daughter board, we've got the solder connections for the foot switch, the mode switch, the PCB mounted potentiometers, and the LED down here. We flip it over, we get to see the remarkably small circuit. There is the little tone bender circuit sitting right there, which is 3 silicon transistors. I'm gonna grab the SMD codes off there in a second. There's actually 4 transistors, and my guess is that probably has to do with the mode switch. Bringing this mode switch, just from playtesting it a little bit, increases the gain, increases the output, and gives it a mid boost. That's what the documentation says. The original Mark III tone bender, of course, only had 3 transistors, which is gonna be probably these 3, and then this little extra transistor here might be a extra gain stage or a buffer somewhere to drive more current through the following transistor. So that being said, the only connections I'm really seeing for the mode switch here are a couple resistors and a capacitor here coming into the switch, I'd assume. The little transistor here might actually not be associated with the mode switch at all. It might just be like a buffer to make the pedal play nicer when it's following other pedals. Germanium fuzz pedals of this vintage were notorious for being susceptible to their position in your pedal chain. They really wanted to see the high impedance reflected from the guitar pickups going into the circuit. At least that's how you achieve the sort of typical or desired tone bender sound. They might be using this transistor here to make it more pedal friendly in the sense that it can follow other pedals and still get the desired effect they are looking for. The foot switch has that sort of lighter green color to it, but it's a heavier actuation than the foot switches that I usually see with that color. These are the foot switches from lovemyswitches.com, and there's a pretty big difference between the force necessary to actuate this foot switch and the force for the Love My Switches foot switch. So it's not always that these green ones have that lighter pressure. It does feel lighter and more crisp than the standard blue foot switches, so it feels like an improvement there. Little indication LED has a little protector around it to keep it stable and strong. That's nice. Potentiometers are the Alpha 9mm PCB potentiometers. The values are audio 100K for, what would that be? That's for volume. 50K linear for tone. I believe that's a 1K linear for the fuzz pot, which would make sense. Transistor codes appear to be K1Q. It's a little hard to tell, they're very tiny. Yeah, I'm gonna say K1Q, perhaps K10 or K10. All 4 are the same. Got a little protection diode down here along with this rather large surface mount capacitor. It's probably power filtering and polarity protection. In here, 2.2 microfarad is going to be a coupling cap and a 10 microfarad cap here, which could be a bypass cap around one of the transistor stages. So yeah, there you go. That's the inside of the JHS Bender. Let's go ahead and put it back together. All right, that was a teardown of the JHS Pedals Bender. If you have any questions or recommendations for a pedal you want to see on an upcoming teardown episode, let me know in the comments. If you enjoyed the video, I'd appreciate you hitting the like button and subscribing. I'm Joe from Gray Bench Electronics. Thank you for watching.